is, since it's a percent composition, we're going to assume 100 grams. What that means is that we will have a percentage and we will just change it to be grams. Meaning we're going to look at that little percentage and we will scribble it out and say that it is grams. Okay? Like literally that. Or if it's given to you in grams, you're just going to leave it alone. All right? So this is more if it's given to you in percents. That you can see like in the first question, right? All of those are in percents, but number 2, I give you stuff in grams. All right? So that's the difference. All right, so step 2 is we are going to convert our grams into, what's the universal unit that we've been using? No. Moles. All right, so grams to moles. So the way that we convert grams to moles, just to remind us, okay, is we had some sort of a number with grams. We did times in a line, right? Grams comes down to the right. Mole was on top. This is where we said 1 mole was equal to our molar mass. So ultimately, what were we doing in order to convert from grams to moles? We were dividing. We were dividing by the molar mass. Okay? So, there we go. We're dividing by our molar mass. All right. So, we're going to do that next. So, we're going to get our moles. Then we're going to look at all those answers that we get. We're going to divide them all by the smallest value. Okay, the smallest number. Found our answers to whole numbers. And those whole numbers are going to become our subscripts. Okay. Okay. All right, so number 4, this is the one where the exception is going to come into play. All right? So if we end in something like a 0.5 or 0.3 or 0.6, that's what you see on the green page, okay? We're going to have an extra step. So when we get there in question number 2, I'll make sure to show you what that is. All right? All right, so let's dive right into example 1. So we have everything given to us in percent. So our first step is we're going to assume a 100-gram sample. So we're going to go ahead and write out what those are in grams. This is what I mean by assume a 100-gram sample. We're just going to take this, say grams, grams, and grams. All right? No conversion, nothing like that. We just assume a 100-gram sample. All right. So then our next step, we're converting these all to moles. So I'm just going to write them out in grams first. And I know that converting them to moles, we're going to be dividing by the molar mass. So remember, molar mass comes from your periodic table. So the periodic table for sodium should be 22.99. And we put that with 1 mole. That's the conversion. This is a step where you actually do not want to be rounding too much along the way. So I would keep it to 3 decimal places. I know that that's a little different from what I've been telling you, but we found a hiccup in a 5th period that it did matter whether you were to the 2nd or the 3rd. So we're just going to, for empirical formulas, keep your digits to the 3rd. As far as you can. All right, don't worry about the molar mass part. That's not a big deal. All right, so we converted to moles. So let's go ahead and go to the next element that we have. We have sulfur. Sulfur is 22.65. We're going to divide it again by sulfur's molar mass, which is 32.07. So I'm getting 0.706. And then finally, oxygen says 44.99. I'm going to divide that by 16.00. So 2.812. Okay, so I've now converted everything into moles. So step 3 says you're going to look at all 3 of those numbers now, and you're going to divide them all by the smallest value. So hopefully you're able to see that this is your smallest value, right? The 0.706. So we're going to take them all. We're going to divide by 0.706. What that does is it allows one of them to be the number 1. And that's what we want. We want everybody to relate to that one being the like 1 to 2, 1 to 3 ratio, things like that. Okay, so one of them has to come out to be the number 1. So once we do that, we start plugging them into the calculators. We're going to get let's see here. 1.994. This one is 1, and then that one is 2.812 divided by 0.706. 3.983. All right. So I've now divided all of them by the smallest. I'm going to take those answers, round them to whole numbers. So this one is about the number 2, this one is equal to 1, this one is about the number 4. So with those, now I'm going to go ahead and put those as my subscripts. So Na2SO4. And so you're able to figure out the empirical formula from that. Okay? Okay, so you're going to be using that technique in the little mystery thing that you guys will hopefully get to start tomorrow. All right, let's take a look at example 2. So example 2 says we have an analysis of a 10.150 gram sample of a compound known to contain only phosphorus and oxygen. Indicates that a phosphorus content of 4.433 grams. What is the empirical formula for this compound? So if you notice, there is no percentages on this. There's only grams, and they only gave us the phosphorus grams plus the total, right? So is there a way that we could solve for oxygen?
Yes.
What? What would we do? You got it. Go for it. There is. Does anybody? Subtract? Mm-hmm. Subtract. Right? So this 10.150 is a total. We're going to subtract the phosphorus, so 4.433, and that should get me oxygen, right? So if we subtract those two, we should get 5.717. of oxygen. Okay? So I expect you guys should be able to read a problem like that and come up with that conclusion. All right? So make sure you guys are thinking outside the box. You got this. All right, so we subtracted it. So now I have grams of both of them. We don't need percents. We don't have to do the first step, which is assuming a 100-gram sample. We're not doing that. We have a 10-point-something gram sample. We're going to leave it with that. So the nice thing about now that you guys know how to convert to the mole is that the percents aren't as important to get that value because technically moles are based off of those percents. All right, so we're going to go ahead and just start at step number 2, which is converting our grams into moles. So I'm going to go ahead and have my phosphorus line first. So I'm going to go ahead and have 4.433 grams. I'm going to convert that to moles by dividing by the molar mass, which I think is 30.97. Can someone back me up on that? Phosphorus? Huh? Okay. All right, 30.97. And that will get us our phosphorus in moles. And oxygen, we have 5.717. We're going to multiply, we're going to divide by that 16.00 grams. So we're converting both of these to moles. This is going to be for sure the example that you have to go to the third decimal place. This is where we had the struggle earlier in the day. So 0.143 for that one, and then the .357. Okay, so I've converted both of them to moles. So what's the next step? We're going to look at the numbers, divide them all by the smallest. So out of these two, this one is the smallest. So we're going to go ahead and divide it by 0.143. Let's see what we get. So this one is obviously 1. This one you get 2.496, which if we're taking it to the third decimal place would be 2.500, right? So we have something that is ending in 0.5, all right? So this one is the one that you have the exception on, all right? So looking at the green page, let's see how we're going to handle that, all right? So on the green page it says, if we end in something with a 0.5, we're going to multiply everybody by the number 2, and that's to get it to a whole number, all right? If it would have ended in a 0.3 or a 0.6, we would have multiplied everybody by the number 3. I'm going to try to keep you guys away from this one as much as possible because it's a very gray area on that one. But I think unfortunately it shows up in one of the mystery questions, so I'll give you the heads up if you ever have one like that. But this is what that looks like. All right, so basically we ran through all the steps and we're at this. We're at P102.5, and we know that we've never seen it be little decimal numbers like that, right? So this is where we're going to take the whole thing, we're going to multiply it by the number 2. So what that means is now I'm going to have P2, what? What's 2.5 times 2? 5. P2O5. That's your final answer. So example 2 is an example of one that you do have that additional step. When you go to start doing some of the practice problems, number 10 is the same exact thing, or same exact way. It's one of those exceptions, okay? All right, so now, okay. So as you guys are hopefully finishing that one up, or if you didn't get through the whole thing, at least write down the answer to check later. We should be coming out to CH4.